The objectives of this presentation are to show the instrumentation for Fixin plate application, the Fixin conical coupling mechanism, different techniques for temporary plate application, locking screw insertion, and implant removal. Implants used for this exercise. The 3.0 to 3.5 instrumentation set. 2.5 mm drill bit for 3.0 screws, 3.0 mm drill guide, 2.9 mm drill bit for 3.5 screws, 3.5 mm drill guide, 3.0 to 3.5 series depth meter, 3.0 to 3.5 series screwdriver, 3.0 to 3.5 series bushing extractor. The support of the large system will accept 3 mm Fixin screws and 3.5 mm Fixin screws. To insert a 3 mm screw, the 3 mm drill guide is inserted into the bushing and a hole is created perpendicular to the plate using the golden 2.5 mm drill bit. To insert a 3.5 mm screw, a silver 3.5 mm drill guide is inserted into the bushing and a hole is created perpendicular to the plate using the 2.9 mm drill bit. Both screw sizes of the large system are inserted using the large system screwdriver. The Fixin system coupling mechanism consists of a stainless steel support with threaded holes and a titanium bushing that is screwed into the support, which allows the insertion of a titanium Fixin screw. The Fixin screw has a conical head that matches the conical shape of the bushing. It has a hexagonal recess to accept the screwdriver, a threaded part to engage the bone, and a self-tapping tip to create threads in the bone. In addition, for temporary plate fixation, bone-holding forceps, conventional bone screw, 1.2 mm K-wire, pin stopper large series used with the golden 3.0 mm drill guide. The V3303 bone plate is used in the exercise with Fixin locking screws. For the exercise, the generic bone model is placed into the vise. The golden 3 mm drill guides are placed into the most proximal and most distal holes of the bone plate. They are used to manipulate and position the plate on the bone. Before locking screw insertion, plate positioning is evaluated, and the plate is temporarily stabilized to the bone to counteract rotational forces. By doing so, the helicopter effect is counteracted during locking screw insertion. For temporary plate fixation, different techniques may be used. Threaded pin with pin stopper. The 2.5 mm partially threaded pin perfectly fits into the golden drill guide for the 3 mm screw. The screwdriver is used to unlock the pin stopper. The height of the pin stopper is adjusted so that the threaded part of the pin will securely engage the near cortex when inserted into the drill guide. The pin stopper is then secured again using the screwdriver. The pin is placed into the drill and is then placed into the drill guide secured into the plate. When the pin is inserted, the pin stopper will press down on top of the drill guide and the bone plate, securing the implants in its position. Threaded pin with a locking screw in the drill guide. A 2.5 mm partially threaded K-wire is inserted monocordically into the distal drill guide. To secure the pin plate bone construct, the screw in the drill guide is tightened using the large screwdriver. Conventional bone screw. The plate with the two drill guides is positioned onto the bone. A hole is created using the 2.9 mm drill bit inserted into the silver drill guide. The drill guide is removed and a special self-tapping temporary fixation screw is inserted using the screwdriver. While the screw is tightened, the plate is compressed onto the bone, stabilizing the implants. Small K-wire inserted in dedicated hole. Some of the Fixin bone plates have a small hole that accepts a 1.2 mm K-wire for additional temporary fixation. When plate positioning has been evaluated, a 1.2 mm K-wire is inserted into the dedicated hole in the plate. Although this technique does not compress the implants against the bone, It does secure plate position on the bone and provides rotational stability during locking screw insertion. In addition, the K-wire does not interfere with the plate holes in screw insertion. Using reduction forceps. Bone-holding forceps are applied to secure the plate to the bone. This technique is mostly used for fracture reduction and fragment manipulation. However, this technique is more invasive and may damage the soft tissues surrounding the bone. At this point, temporary fixation is provided by the bone clamp on one side of the plate. On the opposite side, a 2.5 mm K-wire with a pin stopper is inserted. The stability of the temporary plate fixation is evaluated by manipulating the plate and the bone. Locking screw insertion. The 3.5 mm drill guide is inserted in an empty plate hole and secured in the plate by turning it in a clockwise direction. A bicortical hole is created perpendicular to the plate using the 2.9 mm drill bit. The drill guide is removed in a clockwise direction, and the depth of the hole is measured with a depth gauge. The appropriate size and length screw is inserted and firmly tightened. The same procedure is repeated on the opposite side of the bone model. In some instances, it may be difficult to place two drill guides and two plate holes next to each other. It is crucial for the locking mechanism that the drill guide is placed perpendicular to the plate hole. To avoid interference of the drill guides, their flat surfaces should face each other. The last screw holes are filled with locking screws. Finally, the temporary fixation devices are removed. To place a 3.5 mm locking screw, the golden 3.0 mm drill guide is removed, and the silver 3.5 mm drill guide is inserted. A 2.9 mm hole is drilled bicortically to allow 3.5 mm screw insertion. For implant removal, different instruments can be used. Screwdriver. The first attempt at screw removal is done using the dedicated screwdriver. Care must be taken to accurately clean the recess of the screw head, to firmly engage the screw head with the screwdriver, and to maintain the screwdriver in a perpendicular direction to the plate. Now, two things can happen. First, the screw is disengaged from the bushing, allowing screw removal while the bushing remains attached to the plate, or second, the screw remains firmly engaged within the bushing. The bushing is unscrewed from the support. Bushing extraction device. In case the screw head is stripped, the bushing removal device can be used to disengage the bushing from the support. The central stem of the bushing removal device is removed and placed into the hole at the top of the instrument in order to create a T-handle. The tip of the instrument is placed over the bushing, taking care that the two teeth of the device engage the bushing. The instrument is pressed down on the bushing and maintained perpendicular to the support while it is turned counterclockwise. During bushing or screw removal, the conical coupling may disengage due to the different thread pitch of the screw in the bushing. Screw extractor. In case the screw head is stripped and the bushing removal device cannot be used due to damage to the bushing, a screw extractor can be used. A left-threaded screw extractor is connected to the T-handle and placed into the head of the screw. the handle is turned in a counterclockwise direction while being pressed into the screw head. Once the removal device engages the head of the screw, further turning will disengage the coupling of the screw from the bushing or unscrew the bushing from the support.